All right, so this is the first trig unit that we're going to do, and this is kind of an introductory unit where we focus mostly on angles. But for trigonometry, trigonometry is triangle measurement. Okay, but like I said, this unit focuses mostly on angles. So I want you all to think about an angle a little differently than you have in geometry. So in geometry, I think you mainly focus on angles inside of a polygon. We're going to think about angles as rotating a ray about its end point. All right, and so you can kind of see a diagram of that over to the right. So the initial side of this ray is called the starting position, or the starting position of this ray is called the initial side. All right, and then the terminal side is like after you take it and then you rotate it a direction, where you end is the terminal side. So that's the ending position. Okay. And then the vertex is going to be the end point of the ray. Right, an array is considered to be in standard position if the origin is the vertex and the initial side is the positive x-axis. Right, so when we're thinking about these angles, most of the time that's what we're thinking. All right, now you have positive and negative angles. So positive angles are going to result from a counterclockwise rotation. And negative angles result in a clockwise rotation. Right. Let me bump that up just a little bit. So on that 135 degrees, the initial side is the positive x-axis, right? And then you take that and rotate it 135 degrees in a clockwise rotation, counterclockwise rotation, and that forms the angle in between those two rays. All right. For the negative 60, we start with the positive x-axis, and then we rotate clockwise 60 degrees, and that gives you an angle of negative 60 degrees. Right. We'll also talk a little bit in this unit, but more in other units, about coterminal angles. So coterminal angles have the same initial and terminal side. Right. So if I go back to this negative 60 degree angle, I have a starting position, but I rotate in the counterclockwise direction. I started and ended at the same point, but I have a totally different angle. Like that angle, the blue one that I drew, is positive 300 degrees. All right, and then I could do that also with the 135. So I start at the positive x-axis, and then I rotate in a clockwise direction. That's going to be negative 225 degrees. So the starting and ending positions are the same. We just took a different route to get there. Those are coterminal angles. All right, so I'm going to bump over to the Elmos to show you some things about angle measurement that I didn't feel like I could do on the iPad. So let me do that real quick. All right. So I think you guys know, are super comfortable with degrees, but 360 degrees make up a circle. So full rotation all the way around a circle is 360 degrees. I feel like you guys have known that for a little while. Radians, I'm not sure. I think you may have known there was a different measurement in geometry that's called radians, but I don't know if you really did anything with it. I'm not exactly sure what you guys covered on trigonometry and algebra 2 last year. So I'm going to pretend like you've never seen it before. So with radians, 1 radian is the central angle formed by laying the radius of the circle onto the circumference. So I have this little wiki stick, and when we do this in class, I give you guys little wiki sticks so you can do it on your own, but I can't do that today because we're digital or virtual. But you take that radius, that was my wiki stick length, and you place it on the circumference of the circle, and the angle that's formed is 1 radian long. So that's 1 radian. All right, and then I will take it and move it along. All right, and so this angle formed should be 2 radians. So you guys try to fill that in, just estimating it. It's okay. All right, and then we'll keep going. That angle formed from the positive x-axis to that terminal side is 3 radians. Okay, and then here on the other side of the x-axis is 3.14 radians. So I'm going to keep going. That's going to be 4. Five. 6. And then all the way around is going to be 6.28. Okay, so fill that in. You can pause the video if you need to, but I think that really helps students understand what a radian is. And a radian obviously is way bigger than a degree. So what do you guys think that 3.14 is? So the 3.14 is pi. So then the 6.28 is going to be 2 pi. So there are 2 pi radians in one circle. Right. And then for the revolutions, a revolution is another angle measurement. And a revolution is a full rotation of a circle. All right. Okay, so let's talk about our conversion formula, because our main goal today is to be able to go back and forth to different angle measurements. And so if we are talking about degrees, radians, and revolutions, all of them, there are 360 degrees in 2 pi radians in 1 revolution. That's what you'll have to use if you're talking about all 3. Now, if you're just talking about radians and degrees, I think it's easier if we kind of just go for half of a circle. So half of a circle, there's 180 degrees in pi radians. And then we could go ahead and say half of a revolution, but so if we're just doing degrees and radians, I would use 180 degrees in pi radians. If you have to involve revolutions, you go to 360 degrees and 2 pi radians. Okay, So we are going to complete this table together, and your assignment is a similar table to do. So let's just start with 180 degrees. I feel like we already know this because it's one of our rules, but I'm going to go through the process just so you can see repetition and know exactly what to do. So if we want to convert degrees to radians, we take the degrees and we're going to multiply it by a conversion fraction. And those of you who have taken chemistry may be a little ahead of people who haven't. But the conversion fraction is equal to 1. And so the numerator and denominator are the same, but different measurements. So I want to cancel degrees. So if I want to cancel degrees, I'll put degrees in the denominator. I want to change to radians, so I'm going to put radians in the numerator. And I'm going to use this second rule. So I want to cancel degrees, so I'll put degrees in the denominator, change to radians, and I'll put radians in the numerator. Now the best thing about radians is there is no unit on it. And so we don't have to put a degree symbol or write out revolution or something. All we have to do is just give the answer, which is pi. Okay. So now I'm going to take 180 degrees and change it to revolutions. And again, you may already know this, but I'm going to go through the process. Now, when we're working in the revolutions column, we do have to use this first rule. All right, so in the revolutions column, I'm just going to go ahead and put the 360 degrees equals 2 pi radians. We'll just do 2 pi equals 1 revolution. All right, and then the degrees in radians, all we need to know is that 180 degrees is equal to pi radians. All right, so I want to cancel degrees. So I'll put degrees in the denominator, so my degrees will cancel. And I want to change to revolutions, so I'll put revolutions in the numerator. So 1 revolution is equal to 360 degrees. So I can write that as a conversion fraction because it's equal to 1. All right, now the 0 and the degrees will cancel out. And we're left with 18 over 36 revolutions, which reduces to 1/2 of a revolution. All right. Let's look at the next one. It's not quite as obvious. So we have 30 degrees. We want to change to radians. It's the radians column. So we're going to do that same conversion fraction. We're going to multiply by pi over 180 because I want to cancel degrees. So I'll put it in the denominator. I want to change to radians. So I'll put it in the numerator. Now a 0 and a degree is going to cancel. So the numerator, we multiply across, we get 3 pi over 18. And then I would want you guys to reduce that down to pi over 6. So pi over 6 is 30 degrees written in radians. Okay, the next one, I want to take 30 degrees and I want to change it to revolutions. So when we're going from degrees to revolutions, we use the fact that 1 revolution is equal to 360 degrees. Okay. And then the 0 and the degree will cancel out, and we'll be left with 3 over 36 revolutions, which reduces down to 1/12 of a revolution. I don't want any decimal answers on this. I really don't want you using a calculator except for just like a simple, easy, like not a smart calculator, a dumb calculator. Just add, subtract, multiply, and divide to do this. Okay. So let's look at C. For C, we have pi over 2 radians. And first, I want to change that to degrees. So I take my pi over 2 radians. All right, and I'm using the fact that 180 degrees is equal to pi radians. Now what I want to cancel is radians, so I put the radians in the denominator. What I want it to become is degrees, so I put degrees in the numerator. All right, in this case, the pi's cancel out, and we're left with, we multiply across the top, 180 degrees over 2, which is 90 degrees. Now, your geometry teacher may have stressed a lot that you make sure you put the degree symbol when it's degrees, and you might not have thought it was important. But if you just put 90 as your angle, that actually means 90 radians, which is definitely not the same as 90 degrees. So on degrees, make sure you put that degree symbol or it's wrong. All right, so then we're going to take our pi over 2 radians and we're going to change it to revolutions. Now, whenever we're going from radians to revolutions, we use the fact that 1 revolution is equal to 2 pi radians. All right, so I want to cancel radians, so I put my 2 pi in the denominator. I want to change to revolutions, so revolutions in the numerator. Our pi's cancel out. We multiply across the top, we get 1. Across the denominator, we get 4. So that's 1/4 of a revolution. All right, we're going to do it again. So same column, just a different angle. All right. So if I want to take 3 pi over 4 radians and change to degrees, I'm going to multiply by 180 over pi. 180 degrees over pi, I should say. Okay, our pi's cancel out. We're going to multiply across the top. All right, so I'm going to get 540 degrees over 4. And then you can just use your little calculator to do that. That's going to be 135 degrees. Okay. All right, and then I want to change 3 pi over 4 to revolutions. So 1 revolution is 2 pi radians. Pi's cancel out. Looks like we're going to get 3/8 of a revolution. Okay, and the last situation is when you have revolutions, even though they didn't write it, it's in the revolution column. And we want to change to degrees and radians. So don't forget that anytime you're using this last column, you have to use the 360 and the 2 pi. All right, so 1/8 of a revolution, I'm going to change to degrees. So I'll put 1 revolution in the denominator, and 1 revolution is 360 degrees. So I put that in the numerator. Revolutions cancel out. We get 360 degrees over 8, which you can use your calculator to do that division. That's going to be 45 degrees. Okay. And then we'll do 1/8 of a revolution. And change to radians. So revolution wants to cancel, so we have that in the denominator. That's 2 pi radians. Okay, so when we multiply, we get 2 pi over 4 or pi over 2. All right. And then F, we have 2/3 of a revolution. We want to change to degrees, so revolutions go in the denominator, 360 degrees goes in the numerator. When we multiply across the numerator, we get 720 divided by 3. That's going to give you 240 degrees. All right, and then we'll change revolutions to radians. All right, revs cancel out. When we multiply across the numerator, we get 4 pi. Across the denominator, we get 3, and that's it. Okay. And then I'm going to skip down and do J with you, and then I'll let you finish this chart on your own. So for J, we have 1, and that means 1 radian. So 1 radian, and we want to change to degrees. So we want to cancel radians, so pi radians in the denominator, 180 degrees in the numerator. We multiply that by 1, we get 180 over pi degrees, which is weird, but that is what it is. There was no pi to cancel out. You don't have to have pi to have radians, because remember at the beginning, we know what 1 radian looks like. 1 radian is right there. So we're figuring out what that is in degrees. All right, and then we also have 1 radian, and we want to change to revolutions. So we put 2 pi radians on the bottom because I'm canceling radians, 1 revolution on the top. So that's going to be 1 over 2 pi revolutions. It's a weird answer, but it's fine. Okay, so I want you guys to pause the video and do H through K on your own, and then start it back up and check H, I, and K, sorry. Check your answers on G, H, I, and K. Now G was tough. The 225 pi over 180, be really careful, but I just reduced it a little bit at a time. So I knew 5 simplified into both of those, so I divided by 5. And then when I looked at that answer, 45 pi over 36, I knew that 9 reduced into those, and so I reduced by 9 after that. So those are a little bit tricky. And then K is tricky also, because you see pi and you see gradients, but that's pi revolutions, and so it kind of works out uniquely. All right, so your assignment is to go to page 4 and do this whole table number 1.